Catch Mekong, saltwater intrusion and morphodynamics in the Mekong Delta. Status, impacts, and future developments results of a 5-year research project. That sounds very interesting. And you only have 5 minutes to do five years of results. That's a challenge. That is Miss Julianne Hood, I think. So I can give the floor to you.
Thank you so much. Good morning and good afternoon to Hanoi. I want to send out greetings to you. My name is Juliane Hood. I'm from the German Aerospace Center and the Earth Observation Center. And today I want to talk about Catch Mekong and the results of our 5-year research project. So, as you all know, severe environmental impacts of upstream developments for the Mekong Delta are, beside others, lack of water availability and lack of sediment transport from upstream regions. And those leads to riverbed erosion, coastal erosion, less nutrients bound to less sediments, severe losses in agriculture and aquaculture, and increased saltwater intrusion. I want to talk about our collaboration and research project on pressing problems regarding saltwater intrusion and morphological stability of the Mekong Delta. And I want to present only, of course, in 5 minutes, a small share of a large fund of results. And I want to start with a databases that we built up. We needed a derivation of relevant information for the entire Mekong Delta to deal with the issues and the problems. So we used high-resolution satellite information to generate the following information. We used a multi-sensor satellite approach used for high-resolution flood and water dynamics mapping, as you can see here. We did a long-term analysis of coastal morphological changes, found here. We analyzed the consistent long-term time series of turbidity along the entire Mekong River. And we analyzed the long-term information series of the riverbank erosion of the Mekong Delta main branches of the river. And also we used high-resolution satellite imagery to get information on land use and land cover over time. As we heard in the inauguration, communication of project results is very important. So we developed a Mekong Knowledge Hub for the communication of the project results, which can be found there. The next topic I want to share is on salinity intrusion, a future trend analysis. This is a part of our project where hydrodynamic modeling was used to derive information on salinity intrusion in the whole Mekong Delta. This was a comparison of the baseline period of 2000 to 2010 and the modeling of the future time horizon from 2050 to 2060, as you can see here on the lower right. In the green line, you can see the isoline of 4 grams per liter, which is the critical value. And you can see here the results for February-March, which is in a dry season. And this is the most sensitive phase for rice cropping, sensitive to high salinity of the irrigation water, which obviously, as you can see here, affects large areas. And in this project, we found out that there are different driving factors, of course. So climate change, which lowers the Mekong discharge in the dry season and rises salinity intrusion. Sea level rise, which higher the sea level and increases the salinity intrusion a lot. And of course, dam development. And if this discharge is higher in the dry season, the salinity intrusion can be lowered. But all those competing impacts of future drivers need to be balanced. So dam development could offset the salinity intrusion by a really small certain extent, but it's not recommended as a mitigation strategy because of the numerous negative impacts of dam development to the delta. So last topic, I want to talk about the current estimates of sand mining volumes in the Mekong Delta. This is a model combined with a bathymetric survey in 2018 along a 20-kilometer section of the Tran River branch. And the outcome, to keep it short, is an annual sand mining volume of 4.64 mega cubic meters. And we compared this with other results from other groups and also with reported statistics and found out that there is a discrepancy in the volume. So let's say if the sediment transport rates become too small to compensate for the sediment losses from the large amounts of sand mining volume extraction, the relation between the sediment supply and transport capacity becomes distorted. And to summarize, our derived results show that all this puts the delta's future stability into question. We need to balance and mitigate all those things to prevent the delta from further manifold consequences. And if you want to read about all those research related publications, you can find those under the link I mentioned here. And you can also come to my poster booth later to discuss further questions. Thank you very much.
Thank you very much, Julian. Nicely in the time. And you perfectly provided a good overview of one of the several of the main problems in the delta. So it's a good introduction to all the other presentations we have this afternoon. So can I now introduce the second poster presentation from Ms. Bromme about the R&D project VAWR Mekong Delta Planning Support Tools. The floor is yours.
Yes, can you see all the slide?
Yes, we can.
Yes. Hello, everybody, also from my side. My name is Trinh. Today I take part from Bochum in Germany. I want to introduce our poster from the R&D project, the VAWR Mekong Planning, which is coordinated by a team at the Institute of Environmental Engineering and Ecology at Ruhr University of Bochum, led by Professor Stolpe. The further partner institutions in the project are shown all on the poster. Due to time reasons, I will not mention them here. As this is a research project still ongoing, I will introduce the project objectives and our approach. So the project develops a GIS-based regional planning support system for identifying and prioritizing problems regarding water and land use, and for deriving suitable planning suggestions and measure concepts for specific areas in order to increase the sustainability of water and land use in the Mekong Delta. Our first step was to gain a full system understanding, as this is, in our opinion, inevitable to be able to make any useful recommendations for planning. The Mekong Delta is a complex system, you all know. We have here on the right-hand side, we have a map which is like one of the results of our system analysis. If you look closer, and also later maybe in the poster, you see different areas of distinctive water and land use combinations. And I have also put them down here. So with the same colors like in the map. So wet rice and freshwater species, of course, can only be cultivated in freshwater areas where the water bodies in the map are marked in blue. And brackish water shrimp species can only be cultivated in brackish water areas where the water bodies in the map are marked in red. and so on. You see also the other typical land use and brackish fresh water characteristics combinations here. When and where is fresh or brackish water partly depends, of course, on the natural conditions like rainfall, runoff from the upstream, and the tides, but to a large and increasing extent also on the water management by WARs and sluice gates, which is a huge system. So for water and land use, the distribution of fresh and saline surface waters and its management is the pivotal point. Both are interlinked closely and always need to be considered together. Based on the system understanding, the project developed planning questions and furthermore planning objectives, which then will lead to planning support tools. For the poster, we have selected 4 different land uses, and I will show here 2 examples. So I start with the rural areas characterized by rice paddies, which means these are freshwater areas over the whole year, which allows up to 3 crops of rice per year. Wet rice has a high water demand, so this is one issue, especially when cultivated using traditional methods. While before, the annual flooding brought enough fertile sediments to the fields for just 1 crop, now there are 2 to 3 crops, and in many areas the fields are protected by dikes against floodings. This leads to high amounts of agrochemicals going along with all negative consequences for the environment. The most important planning objective here is a sustainable rice cultivation. For the regional planning levels where we are working, the following questions need to be solved. On how many hectares, how many crops per year should be cultivated? First, of course, with regards to the water demand and the available water resources. And second, with regards to the resulting water quality in rivers and channels. The planning objective wastewater treatment in these areas for domestic and small-scale production wastewaters also looks at the resulting water quality in rivers and channels, which is main boundary conditions for further development and for agriculture. The second example are the rural areas with brackish aquaculture. Here we find similar planning tasks. So this is a landscape which is completely covered with ponds, you can see in the picture, and especially the intensive methods lead to pollution of soil and water. And then this poses again a threat to the aquaculture itself, especially when diseases break out. So the system of channels here was actually designed for rice paddies, for rice cultivation, so it is not suitable for aquaculture. So here the regional planning level needs to make specifications on the target water quality, the degree of water recirculation and treatment in order to achieve sustainability for aquaculture areas. So regarding water quantity, the regional planner here needs to look at the groundwater because sometimes it is used also for aquaculture. So I come to the last slide, which is just, it's not changing. Oh, no. So in order to summarize, so we start with the system understanding and develop from this planning questions and planning objectives, and then we'll develop our planning support tools. So the regional planning will have to specify which measures and adaptations in water and land use are necessary in order to achieve a delta system which can cope with the current but also with future challenges. Thank you for your attention.
Thank you, Karen. Very interesting. This project, which is, I understand, still ongoing.
Yes.
And of course, immediately I think about how is it linked to the Mekong Delta Master Planning project, which is ongoing or already almost finished. But we can discuss that maybe later in the Q&A session.
Okay.
Yes, because of that, will just now go to the next small presentation on JICA's activities on climate change in the Mekong Delta region. And you have also 5 minutes.
Okay, thank you very much for your for giving this opportunity to introduce our activities on climate change in Mekong Delta at this conference. My name is Naomichi Muroka of JICA Vietnam office in Hanoi. Today I'd like to introduce JICA's activities on climate change in Mekong Delta regions. First, next slide, please. Yes. First, JICA's activities on climate change addresses both mitigations and adaptations. The amount of our climate change cooperation by JICA to the whole world was around 1,000 billion US dollar in 2018, of which 80% was for mitigations and 12% for adaptations, and 9% for both. Vietnam is one of the most vulnerable countries against climate change, and Mekong Delta, which contributes 95% of the rice exports, 70% of fruit exports, and 75% of fisheries exports, is the most affected areas in Vietnam. So our activities for climate change adaptation, therefore, focus on water security and water utilization in Mekong Delta in order to avoid and minimize climate risks of the people and their livelihood. So I'd like to introduce 2 ongoing projects in Mekong Delta. One is structural measures in Benche province, and the other one is non-structural measures in Kanto. First, structural measures in Benche. It is projected that there will be an increase in economic loss due to the intensifying saline intrusion negatively affecting to the yield from rice fruit and therefore the lives of the people. Moreover, the availability of fresh water is getting less, especially in the inland of Mekong Delta. So under these circumstances, we consider that activities coping with such changing environment while embracing the natural endowment is the direction we should aim at. The optimum balance, protecting people's lives and social environmental considerations is a key for sustainable and climate resilient development of the Mekong Delta. So what we do in Benche, with those background I explained, upon the request from the government of Vietnam, Japan decided to provide ODA loan to Benche water management project in July 2017. This ongoing project will construct saline water intrusion control facilities, including 8 sluice gates in Benche province. It is important to embrace the fresh water to mitigate the damage from intensifying saline intrusion by both structural and non-structural measures, ensuring intake of fresh water from upstream where saline intrusion cannot reach, and controlling the saline intrusion into inland of Delta by optimum operation of sluice gate and sluice gate. Okay. Next. So non-structural measures in Kanto. We are implementing loan and technical cooperation project with Kanto University in order to enhance the capacity of education, research, and outreach in the field of climate change resilient agriculture, aquaculture, fisheries, and the environment by human resource development and advanced facilities and laboratory equipment. With this project, the Kanto University is expected to be the best think tank for climate change adaptations and to contribute to enhancing the adaptation capacity of Mekong Delta and beyond. Next slide, yes. In this project, we are conducting 36 joint research program in 2 years. Many researches focuses on salt tolerance of seedlings of agriculture and shrimp fry or fingerlings of fisheries and environment, such as soil treatment and water pollution and management and so forth, as you see in this chart. In our joint research, local government, communities, and companies bring their issues related to climate change to Kanto University for solutions. And Kanto University then jointly conduct such research, and local government communities and companies will make investment and implement such solutions once such solutions idea become feasible at the field level. So we hope that the MOD and other ministries, international communities will strengthen the collaborations with CTU and utilize the enhanced capacity of CTU for addressing climate change issues and effective climate change adaptation actions in Mekong Delta. So this is the end of my presentation. JICA will further expand its cooperation in climate actions. Thank you very much for your attention.
Thank you very much for this very interesting introduction in the work from which is supported by JICA, and it's very well connects to all the other, problems and issues in the Mekong Delta. So let's go to the oral presentations. We have 10 minutes for the oral presentations, right? Okay. So, Mr. or Mrs., I don't know, Chu Le Xuan Tu is now going to give a presentation on salinity, wind and wave effects on sediment transport at the Mekong River estuaries. That sounds very technical, but also quite important because, as we all know, both salinity and sediment are very crucial elements, factors which determine a lot of the agricultural perspectives in the delta. Okay, there he goes. Yeah, floor is yours.
Hello. Good morning, good afternoon, everybody. On behalf of research team, I would like to present the topic salinity and wind wave effect of the sediment transport in the Mekong River. So, as well known, Mekong River is one of the longest rivers in the world and run through 6 countries, the length of which around 4,400 kilometers. The sediment transport from Cartier here is around 160 million tons per year in pre-1990. So when the dam in the Mekong River Basin completed, that will trap 96% of sediment transport. This is the site from the Condop study in 2014. The suspended sediment transport in the Mekong River, that also studied by the MRC, the Mekong River Commission, during the period 1992 to 2014. The sediment reduced significantly, around 160 to 75 million tons per year. So that's the sediment transport reduced into the Mekong Delta that will make the coastal erosion and also the mangrove forest degradation. So here, both flood and fly season in the Mekong, that also affect to the sediment transport. So here it is the plume of the freshwater and also the sediment along the Mekong coastal. So to know how and what the role of the salinity, wind and wave effect on the sediment transport, and that's varying in the season. This is the objective of this study. So to get the objective, we set up the Del 3D model for this one, and for the upstream boundary, I use the method and contour. This is for the Mekong and Basak River, and along the coast from the Vũng Tàu to Cà Mau Cape, and expanded 70 kilometers to the sea. So this one we set up the discharge in the upstream and the tide for the sea boundary. We coupled with the wave model. The modeling we calibrate and validated already with the observation, and here I show very deeply. This is the water level calibration and the discharge. Here this is the sediment concentration and the salinity in that's the in the simulation and the observation. So we can see that high agreement between the simulation and the observation. Go to the result of the simulation. The first one, I want to show you the salinity intrusion. So here, this picture, I take four picture in a 4 month for dry season. So this occur in the high water slack here, and you know this the salinity intrusion to the mainland that around 40 to 50 kilometer, and that's depend on the discharge of the upstream boundary. So here this one the water waste. So you know that in the river the water salt water waste occur in the flood season, and that's make the highly stratification in the estuary. And this one in the surface layer, the fresh water that moved from the river to the sea, and in the bottom layer, the salinity intrusion to return to the river, and that's make the circulation in the estuary here. And this one, I show you the simulation in the fresh water here in the flood season. The fresh water that's come to the sea here, and the shape of the fruit that depend on the monsoon. In the southwest monsoon, this go to this way, and when it change to the northeast monsoon, this here. So the fresh water that depended around 20 kilometers from the coast, from the along the coast. Yeah, this one for the salinity intrusion. I take for the in dry season, you can see this one, the salinity intrusion very deep to the mainland here. So along the estuary, that's the depend on the discharge and also the tide. And go to the sediment dynamic in the season. So the first one I show the sediment distribution in the flood season. So from this movie, this one this one I show the sediment pumping to the sea in the flood season. So almost the sediment that's deposit in flood in the estuary here, and in dry season, you see that when the sediment concentration in the upstream that reduced significantly, but the sediment in the river and also along the coast that also very high. That is the reason why the highway in the northeast monsoon that resuspended this sediment along the coast, and that's return to the estuary, and the other that's moved to the southwest direction. To make more clearly about this process, I take the cross section here in the Basak estuary here, and you know that in the flood season, the sediment that's the transport to the export to the sea with increase significantly. But here in dry season, that reduce gradually because the sediment from the sea that return again here, so that make the community that reduce here. And also in the sediment transport for the longshore. So this one I show the sediment in the northeast monsoon, in the southwest monsoon. So that's transport a little bit, but in the northeast monsoon, the way and the high dominant. So that's make the transport rapidly here. And to know how the sensitivity of the salinity and way effect on the sediment transport, I take many scenario with no way and salinity, way and no salinity, and way and salinity, and I compare with the satellite image. So we compare how this affect to the sediment transport in both flood and dry season. So we can see that if no way, so almost the sediment only pump to the in front of the estuary here. That's similar, but with way and without salinity, the sediment that pump very far to the coast here, and with the way and salinity. So in flood season, the way is not high, so that's similar with the with no way. But in dry season here, the wave and the current that's very high, so that take the sediment transport in here, and that's similar with the sediment observation in the data. And here for more detail, I will also take the similar the cross section. Here this one for no salinity, so the hue of the sediment that come to the sea, but with the salinity that reduce very much. And also for the longshore transport with no way the sediment transport along the coast that slightly change. But when we turn on the way, that's change gradually in the southwest monsoon, and that's dominant in the northeast monsoon. And finally, go to the conclusion. The first seasonal sediment transport by river discharge and the monsoon, that is the main in the Mekong River. And effect of the wind and the wave salinity, that is the significant factor that affect on sediment transport. The short waves is that push the sediment from the coastal to the sea, and that create the flocculation to increase the sediment capacity during the wet season. And the wind and the wave are the dominant factor that make the resurface the sediment along the coast, and that make the sediment transport dominant in the southwest direction compared to the northeast direction. So this one, it is the result of the study. Thank you for your listening, and if you have any question, I'm very pleasure to discuss.
Yeah, thank you very much. Very well done within the time limit. Very good. Very interesting presentation. If someone has questions, please keep it till the end of the session. And indeed, it is. There are a lot of questions coming up into my mind, but I will keep them in my mind for a moment, because we will have to go on with the next session, the next presentation, which is from Mr. Hung. And it's about local water storage for fruit trees in a drought and salty conditions in the Mekong Delta. So that is a very interesting, again, it very well fits in the whole idea, the whole problem of the salinity, which we heard is increasing, and water storage might be a solution. It was also mentioned earlier by Mr. Stefan Uilenbroek. More water storage is a very important issue. But of course, the Mekong Delta is very flat. So where do you put your water? I'm interested to hear that.
Thank you. Good morning and good afternoon for you. On behalf of our team, I would like to present the academic report, research on local water storage solutions to irrigate fruity in droughty and salty conditions in the Mekong Delta. My research content is 6 parts. The first one is needfulness of this research. The second is objective. The third is approach and methods. The fourth is proposing solution for water storage for fruit tree. And the fifth, applicability. And the last one is conclusion and recommendation. And here is the Mekong Delta map of fruit. Is concentrated in Tiên Giang, Bến Tre, Vĩnh Long, Cần Thơ, and some place. And we know that the total fruit area in 2018 is Mekong Delta is 60% of Vietnam, and also total fruit production is also 60%. And The first one is the needfulness of this research. This requirement from actual fruit tree production in Mekong Delta. And his upstream, the upstream flow of Mekong Delta affect the fresh in the Mekong Delta and rain season in Mekong Delta chain. Salinity intrusion to the upstream is very deep, and many fruit tree is die, and the people have to cut it, and people have to buy clean water from upstream from Dong Thap province, price from 100 to 150,000 BND per cubic meter to irrigate for plant. And the second one is the requirement from government and Ministry of Agriculture and Rural Development, and need ensuring approach production in all situation, need water supply, and minimize damage caused by salinity shortage for fruit, and solution for water storage must be suitable with condition of natural and soil property and plant type, and suitable for economic condition of the region and the orchid in the Mekong Delta. And here's the overall object and specific object. We show that the diagram of approach and research methods, and we collect data, finally analyze, shows methods from experiment, determine approach farming technology, and find efficient water saving irrigation process for fruit in the Mekong Delta. And finally, we have the water solution, storage solution to irrigate for fruit tree in the Mekong Delta. Solution for water storage. Here is the, we calculate with the 14 type of tree: durian, mango, pomelo, orange, banana, pineapple, red tree, mangosteen, and with the salinity tolerant, plant density, water requirement for irrigation. And we calculate in 5 months, January, February, March, April, May, and December, each fruit tree time here. And the next, we determine the amount of water loss with the formula number 1, and we look for the methods to reduce evaporation and infiltration. Here is evaporation in the dry season in the Mekong Delta. In 13 provinces, Long An, Tiền Giang, Bến Tre, Trà Vinh, Sóc Trăng, Bạc Liêu, Cà Mau, Vĩnh Long, Kiên Giang. And we calculate store water in the ditches during the dry season in formula number 2. Here is, for example, we determine the total amount of water stored in the ditch in the formula number 3, and we set up the table here to give for the farmer can apply. Here's the bank and here's the ditch. And here's the storage water in the pond and lake during the dry season. Auxiliary work connected with pond and lake is including canal, sluice, and pump to support for the system. And we determine the size of pond and lake in the formula number 4. And we also set up the table for the farmer to apply in the actual production. And here's another method: storage water in the bag during the dry season. That just depend on irrigation demand and area to put the bag in the orchard and the farmer financial to set up the bag. And the fifth is applicability, is marketability, applicability of the research to the farmer production. The joint venture possibility with the enterprise during the research and transfer modality. And here we apply for the pilot method of pomelo at Tiên Giang province in Mekong Delta. This is the model. It's the length here, the wide. This is the ditch and canal. Here the bank. This is the main river. It's how the farmer house. And the last one, we made the temporary guide note on water storage technique and efficiency irrigation for fruit tree in the Mekong Delta. And this we give for the farmer in the Mekong Delta to apply in this dry season. And the last one is conclusion and recommendation. With the conclusion, this study is an order from the Ministry of Agriculture and Rural Development. And this research result have been identified the solution of local water storage for orchard, how to calculate the water amount to be stored, and contribute to develop and implement the agriculture and structuring strategy, which has many potential here. The last is a recommendation. It's necessary to carry out a detailed study on salinity tolerance of fruit tree in the Mekong Delta. And the government and management agencies should support and propagate the people to apply this useful solution in production, maintaining and developing orchard extremely salty drought project period. Thank you very much. Here is toward development of Mekong Delta becomes a proper sustainable and rich identity. Thank you.
Thank you very much for keeping exactly in the 10 minutes. Again, a very interesting presentation, very concrete examples of solutions and how to calculate the solutions. Of course, I really would be interested in what the farmers think of it and how they can use it. Because it's not only a technological problem, but also a matter of finance and acceptability, etc. So yeah, keep your questions, and we go to the next speaker. Is what is what? Miss Min, Miss Nguyen, Min. Mekong Delta shoreline responses to changing human interventions based on a numerical model. Sounds very technical, but also very important because, yeah, sediment problems can lead to coastal erosion. We all know that. So it's very good to have more information on that. The floor is yours.
Good morning and good afternoon. Firstly, I would like to thank you for giving me a chance to present our research. And today I would like to present the numerical research on the Mekong Delta saline response to changing human intervention. You know, the Mekong Delta is one of the largest river delta in the world. And for thousands of years, the Mekong Delta forecast SIWRR due to a large river sediment input. And this picture shows you the satellite analysis from 1990 to 2015, and the red color represents for the erosion area. And since the middle of the 20th century, the delta may be eroding. Our study indicates that the substantially of the saline evolution is a result of natural redistribution of the sediment, and many factors involved in the erosion process, such as the river deficit due to the dam construction and sand mining, and subsidence due to the ground water extraction. In this research, we try to involve all the factors could be affect on the erosion process by developing a three-dimensional model. This is our research numerical simulation, and we try to cover all the factor effects in hydro and dynamic sediment in this area by focusing at the river discharge, the tidal, the wind, waves, and sediment. We include also the cross-salt process and the salinity stratification effect in this model. This may be in the two-dimensional model might miss. And this ER model, we use the oceanal model with the ocean circulation, the atmosphere, the wave, and the sediment that to recover on the interaction between to ensure that on this factor could be has the role on each other. This is the numerical domain, and we had the input from the Gunther and Meechaiya station with the sediment concentration and the fresh water, and with the tide from the TPXOS and the current from the ECO and the wave from the ECMWF. We validate with the currents and the significant wave height from the institute method, and this so a good consistent between the model and the measure. We validate also with the different station of the salinity profile along the coast, and you can see that the very thin lower salinity upper part, less than 5 meter in this area, associated with the higher river discharge from the Mekong River. This is a stratification effect. And we are showing now the cross-source section for the salinity. This is the bottom, and this is the surface, and this is the bottom. And the red color represent for the seawater, and the blue color represent for the fresh water. And you can see during the winter season, from maybe a little difficult to see, from the November and December, January and February, the fresh water is formed a very confined plume along the coast, opposite to the season, for the summer season, and the plume is thinner, but more far away from the coast. In our simulation, it reached up to 70 kilometers offshore. And this is the cross-shore section for the longshore transport. And it forms a very strong but narrow and deepen the coastal jet from the north to the south during the winter season. And during the summer season, the current is much the less and thinner, and this is more clear observed in the section number 2. Section number 4, I forget to present the different section. You can see that during the winter, very strong and closer to the coast, and deepen. And during the summer, we couldn't observe that. And this, if we calculate the sediment flux along the coast by calculate the cross section, and here we found that the strong surface coastal jets bring more sediment to the Kamau Peninsula, and even enter the Gulf of Thailand. And we found the final resolution give the larger sediment flux into the Gulf of Tonkin. It's maybe explain the impact of the sediment river in the Mekong Delta, maybe up to the Gulf of Thailand. This is a validation model with the different author, with the research from the Anthony, and with the satellite analysis, and also this is our model. And we found that's a very similar tendency between the erosion areas and the deposition area. We conclude that a three-dimensional structure of the coastal flow and sediment transport has been described, and the reason of the freshwater influence plays an important role in generating coastal current and the sediment transport in the Mekong Delta River. And the importance of the 5 sediment volume found in the Kamau West coastal zone is maybe the original of the Mekong River. And the next part, we try to evaluate the effect of the reservoir contraction. Many the researchers analyze and try to demonstrate before the dam construction and after the dam construction, and with
1 minute.
Okay, and maybe so the next part, we will try to reduce the sediment concentration in the river station, and this is the kind of the result from the satellite, the SPM, it shows the decreasing of the sediment, suspended sediment in the estuary area and also in the western coast. And this is 1 month simulation. We can see the deficit of sediment in this estuary area, and we try to calculate with the 5-year simulation to see how the river sediment deficit effect on the coastal area, and the most effect on the estuary area, and also in the western coast, the sediment flux was reduced by about 25%, and after 2 years.
So you have to stop. You really have to stop.
Maybe we can conclude a little bit on the river deficit. In this is sensitive by the simulation, numerical simulation, and now we can see that along such transport set the pattern of the erosion and the deposition, and the estuary area is the most affected ones by the sediment deficit. And the model show also the reduction in the river supply is not likely to affect the downstream Canal Peninsula at the same time scale, maybe time next 1 or 2 or 5 years. Thank you.
Thank you very much for your interesting presentation. We have very limited time, so we continue with the next speaker, Mr. Vo Quoc Thang, talking about the sediment budget for the Mekong Delta using a process-based model. So we continue with sediment. Sediment is very important this afternoon. So it's all about sediment, not about water, but about sediment. Okay, the floor is yours. 10 minutes max.
Ladies and gentlemen, thank you for your inviting me to this session. So I'm waiting for him to share with the online participants. Yeah. Yeah. I'm waiting for him to share the screen, so the online participant can see what I'm presenting. Mở to rồi, mở to rồi. Okay. I'm going to present research on regional sediment management in the Mekong Delta. So the title here. Actually, my presentation contains 4 sessions, like introduction, method, research, and conclusion. Actually, when you hear the presentation from Tu and Min, so you can understand the general condition of the Mekong Delta. So actually, I have some right here. The Mekong Delta is one of the largest rivers around the world, and some information about the Mekong Delta. So what happened in the Mekong Delta? So the Mekong Delta is dealing with some human activity, like upstream hydropower dam. Like here, you can see the series of power dam along the Mekong Delta, along the Mekong River. And so the upstream construction will change the flow region and changes the sedimentation in the Mekong Delta. So here you can see the picture. This is the color of the water at Kong Tơ City around 5 years ago. So you can see the color is quite clear. So it's clear with less sediment, with less sediment concentration in water column. And another kind of human activity, like in the delta, the delta base construction, here it's like high dye system. Here you can see the land use map of the Mekong Delta, and you see that the major livelihood of the Mekong Delta is rice. And you can see the yellow one is the triple rice cropping system. And actually, here is the upstream of the Mekong, Vietnamese Mekong Delta is dealing with the flood season. So to protect the rice crop during the flood season, they have to build a high dye system. And here is the high dye system in the Mekong Delta. And you can see that during the flood season, inside the high dye, they can still growing rice, but outside is it flooded. So these constructions like hydropower dam or other human activity maybe change the sedimentation in the Mekong Delta. So the recent research they show that there are like a SIWRR program. They're dealing with the shoreline erosion, and that my college just present that the shoreline erosion along the Mekong coast. And actually, one of the major causes is related to the sediment supply from the Mekong Delta, Mekong River. So my research is to investigate suspended sediment dynamics and derive a sediment budget to understand the sediment budget in the Mekong Delta. And I'm using the process-based model. And actually, you can see here is the river network in the Vietnamese Mekong Delta and the whole Mekong Delta. So you can see it's very dense, and it's because the width of the river is varies from 10 meters to around 4,000 meters. So to deal with this problem, because I'm using the numerical. So to deal with this problem, I'm using approach that I'm using what is 1D and 2D coupling. And here you can see here is a 1D. I'm using 2D for the mainstream of the Mekong River, the floodplain, and 1D element is for primary and secondary canals. Here's the full domain that I'm using to compute the hydrodynamics and sediment transport. And if you look at detail here, you can see it's quite detailed. And about the length of the ridge is for 1D element is around 400 meters, and for 2D cell is depend on the shape of the river. It's varies from 200 meters or to increase to 2,000 meter from the confluence to the sea. And actually, the coastal of the Mekong Delta is influenced by tidal processes like tide and waves. So I'm using the wave influence on the suspended sediment. And here is the model setup. I'm using the time series for water discharge, and actually the suspended sediment concentration I derived from this rating curve. And actually for the downstream boundary, I'm using the water level. I'm using the tidal component that derived from the global tidal model. And for the cross-shore boundary, I'm using a Newman boundary. And actually, because it's a quite heavy model, I'm just using for one single fraction. That's a multi sediment, because former sediment in the Mekong Delta is influenced by salinity as well. So the falling velocity is quite different in the freshwater and saline water. And here is the calibration of the hydrodynamics model. As you can see that I'm using a NASA cliff efficiency indicator. If you can see that the color is indicate the value of the NASA cliff efficiency. The highest one is mean that the good agreement between observation and measurement. And for calibration the model sediment model, I'm using like an approach. Generally, to deal with the sediment modeling, we have to deal with the falling velocity, critical basis stress and erosion gauge. And so I'm using this metric, and this is calibration parameter set here. And actually, here is a comparison between measure and computed substandard sediment concentration.
1 minute left.
And actually, here is the like one of the first figure that you can see that I'm confused about the sediment budget in the Mekong Delta. You can see that at Krachi, the annual sediment volume is not like 160 million tons per year, like the US study. They said that this is for the highest water year in 2011. It's around 100 million tons. At the Vietnam and Cambodia border, the sediment transport into the Vietnamese delta is just around 79 million tons. And at the coast, the river, Mekong River distributed they struck around 23 million tons per year in 2011. And this is some my research brought some conclusion here. Is the sediment supply to the Mekong Delta is not like is not high like the US estimation, and actually the erosion gauge is an important parameter when we deal with sediment modeling. And actually, the sediments Mekong Delta, the Mekong Delta is the high that chopping efficiency of the Mekong Delta is very high. Yeah, thank you.
Thank you very much for this very interesting presentation. Very important also for the future, and I'm looking forward to see your final results when your study is finished. Next presentation will be on the salinity forecasting and water quality data knowledge platform in Meechaiya and Chavin. Presented by Ms. Din Phuong Chan of Deltares. The floor is yours.
Good morning and good afternoon, ladies and gentlemen. I'm very happy today to give you a presentation about our result of a 5-year project that we have been done in Mekong Delta, also in very close cooperation with the Vietnam Academy of Water Resources and Southern Institute of Water Resources. So our system is focused on to developing an operational and salinity forecasting system and water quality data knowledge platform for Meechaiya and Chavin province. And This is a part of the project that is funded by International Fund of, for Agriculture Development. And with the name of the project is the Adaptation to Climate Change in the Mekong Delta in Meechaiya and Chavin Province. And it has been implemented also by Meechaiya and Chavin Agency. The main objective of the project is to provide the timely salinity information and forecasting for both provincial authority and also for the external users. So in the very specific objective is providing also the information for the water management to also improve the freshwater supply management for agriculture and aquaculture, to provide also the forecasting information to support the local farmer to reduce the risk in the production. And also it supports the provincial authority for both short-term and long-term management planning. And our system is developed based on one of our free of charge software developed by Deltares. It's named Delphi. And Delphi is a platform for operational system worldwide, which is currently using also as a national hydrological forecasting system all over the world. For example, we have the national system in US, in Korea, or in Australia, and we also is the one who have also the Vietnamese national hydrological system for Vietnam. And we also have a very, we have a user community worldwide that we also organize annually meeting to also support our user to improve our software, also discuss about how to upgrade it. And the Delphi is have various applications, even it firstly start just for flood forecasting system. That is the reason why we call it field, is the flood and early warning system. But then by time we already apply it for a various application from water quality to the real-time control for reservoir, for the coastal water quality and coastal forecasting system, and also for the groundwater. So then I will give a very short demonstration on how we have been developed the field system in Meechaiya and Chavin, and we use the name of the project AMD to put the name for the system, and we call it the field AMD system. The field system, basically it developed based on basically workflow of a forecasting system. And it always starting with the data feeds from the either from monitoring station or also from meteo data forcing from global data. And we have also the processing data, the processing module to help you to pre and post processing into the system. And we have the model adapter which help you to integrate the various model into the Delphi system. It either the Deltares software or also either other software from other developer. For example, we also can integrate the software from DSI, the My model, into our Delphi system. And the result of the model when can visualize it in our GUI, that actually the user interface that you install in your computer. And you also can export it through a model that gives you the automatically daily reports. And this is how the workflow we developed for Tylomet and for the field system in Meechaiya and Chavin. When we see that it have the basically three main pillar. With the central pillar, it's the central database where you store all the data, and you have also the module to import the data automatically into the central database. And then in the central database, you can be processing the data, import it into your model, get the model run automatically, and get back the model result from the model, visualize it into your computer, and then export it either to the website, to the mobile app. You also can send it in HTML text, or you also can store it in your server. And now I will going into the pilot. So for the import data for Benchen and Chaving, we import into the data from the automatic monitoring station, which it measure the basic water quality and salinity parameter in the Mekong River. And we also forcing in the upstream river discharge forecast from provided by Southern Regional Hydromet Center. And we use also the downstream data from HICOM from NOAA that it provide you the forecast on the salinity and seawater level. And this has how it look like into the system. We have the upstream boundary condition at Tân Châu and Châu Đốc. And we forcing in also some meteorological data from GFS. And in the downstream boundary, we use the HICOM. And how this is how it look like in a map display into the field system. It can be, you can see all of the station, all of the points that you already extracted into the field, with also the upstream boundary, the monitoring station in the river, and also the HICOM in the coastline. And how is display in field? And you can either display it into the spatial display or into the grid display for the meteorological forcing data. You also can do it similar thing with the global data for from the coastal forecasting model. And you also can display it, for example, for monitoring station, you can display the data into the graph or into the chart. You also can display it into the table, and you can even edit it directly into the field system. And you, for the salinity, we also provide that you also can display it into the profile according to the river. And this is the model that we developed for the field, for the salinity forecasting, that is basically based on our SOBIC model. It's the most updated in SOBIC 3. And actually, it's also we make use at the our model developed from the previous study of Deltares. It also makes it one of our PhD students from the University of Utrecht. And with the data and also support from the local knowledge from Southern Institute Water Resources, we did calibrate it and validate it. And finally, we integrated into the field system. And this, the big picture you see that how it display into the field system, into the spatial display. And it is the most important one that I think that we have a lot of forecasting system, but it's the question that how is the external user can be received the forecasting. So in the field system, we develop and also we disseminate the forecasting data and also the observation data to different users. As the first thing that we, for the forecaster and also for the authority, the water method authority, you can usually that observe it into your PC with the software GUI, and you also can export it automatically into your website. For example, in Meechaiya, I think we export it automatically into the web page of the Department of Environment. And then we also develop a specific mobile app, which also called Field AMD, to disseminate to external user, which is not the provincial authority. And then for this, we can help to get either as farmer, either institute can get access to our system. Thank you very much for your attention.
Okay, thank you very much. Now the last presentation is the Nguyen from the Southern Institute about master plan for river training in the Lower Mekong. So we are now again into the river erosion, river sedimentation, river training topic. There he goes.
Oh, sorry. Actually, I'm chair, but Marcel is very good in sharing and keeping time. So I have no job. I back to the floor for some story about Mekong again. Thank you again for inviting me to the conference, and also good afternoon and morning to everybody. So this actually is funded by VAWR's project also for master plan for the Lower Mekong River, but mainly focus on the Lower Mekong in Vietnam. So I don't mention again with the Mekong because many colleagues already mentioned, but I just apparently saying that we have a very long river with large basin, which apparently have influenced by climate change and also the water security for the whole six country. So talking about the dam, my colleagues also already mentioned, and also the delta development and sea level rise. But you know, for 2010, the latest updates data about the active storage of the upstream dam about 65 billion cubic meters, means about 1/3 of flood volume for the river basins. And in future, if you keep the same planning, maybe going to 110. So the delta keeping a very important, but you see it's they have mainly rice with gray color, rice stream. We have aquaculture and also fruity and orchards for vegetable. So this own kind of activities influence to the flow of the main river and also the channel network. So my talk about the main river, and some colleagues are talking about the main river, including with sediment along the coast, but how in main river reacting to the system. Here you have a hydraulic system. Some is already closed, some is already opened. So you see here is about 14 system. We have numbers 13 is Kai Lân, Kai Bé is sluice gate, big sluice gate system. So this reality happening in the activity of the Mekong, where we have a north Pente and South Pente and so on. So this already 2 million hectare is already under control by hydraulic system. Somehow, some open, some is closed, but it's already having this. We also have a fragment of the urban area where we have here somewhere is Cần Thơ, Long Xuyên, Khao Lanh, and is Châu Đốc and so on. So it's Ho Chi Minh City. You see, along the river where we have this urban system, and in the other side we also have the red is the erosion system. So we have the more upstream, we have the more erosion processes. We also have flood in the past, with a few historical like 2011 and 2008 somehow, 18 somewhere, and 2000 here we have this normal flood. Above this part we have a higher flood area, but nowadays almost flood is below what we call dam trapping. As I said, here you see some historical flood protection. Flood also have bring very good quality for like ecosystem and also for food for fish. But we also have diversing with saline, as mentioned before. But you know, the problem is with Barsak River and Tien River, in parallel with the river system and coastal, they have a different part of the flow. So this meaning like freshwater distribution in upstream may be effect to the downstream saline. In Delta master plan in I think is 2013 with national support. They also mentioned about the river corridor, but it's a little mentioned. So we don't have any other master plan for river at this moment. So we really think it's important because the main brain of the flooding system is already here for flow, also for sediment diffusion, and also for the saline intrusion. So if we see saying about the flow distribution or sediment in upstream in somewhere here Chatamuk in Phnom Penh, we have like 80 to 90% of flow, and the other like Basak is about 10 to 20. And then here is very important when flow is divert to the Basak River through the Bam now, they have more or less 50 to 50%. So I'm trying to get where is the importance of the river system that we have. We have one here in Phnom Penh, one here that I mentioned before, and then we have the conjunction here, and we have in total 8 bifurcation nodes that can be control the river system and the river morphology. We also mentioned about the 8 location where we have a river braided, where we have more islands and more river freedom in terms of landform change. So we have here 8 locations where we identify for the master plan that should be somehow to control and to protect for keeping the same shape of the river in future. We identify also the main cause of the river bank erosion and housing, where we have here sand mining loss as mentioned about, I think, Julian poster introductions. We have also many other very detailed activities that we have for sand mining, and also activity for charting and fish pond also one important. Talking about the node at Phnom Penh, you see that we have here the channel for Tonle Sap, where we have a reverse flow, and we have here Basak about 3,000 to 4,000 is about 10%. He also sediment somehow with group of Dhabi and in UK already measure this distribution for. I think my colleagues already mentioned about the substandard sediment, but the most important is near bed sediment, like bed load sediment is more important for downstream. However, you know, in Phnom Penh they have a very high rate development now. Is I think it's like Hong Kong. You see here it's about 5 kilometers in length and about 1 kilometer in 700 meters in width. They already city development moved to the river ward. You can see here some picture and some. This is already the latest the last 3 years. So this means they change the flow rate in dry flow in that Basak and the Tran River conjunction. We also have after Tanchou the number 2. So I just very selected few. So you see that is a study here in I think the last in the past 100 years, the main flow is coming to this direction, and now it's moved to this direction. So this also a very movable. You can see here it's movable banks and should be a control system that's taken into account. You can see here where we have a very sandy bar, and this also a region that unbalanced sediment that erosion into the island, and then is compensated for the sand mining. Many other places like Long Xuyên is also one of our colleagues study about physics modeling also. They have a main problem with the housing collapse, and also problem with the movable and different changing the river distributions. Here's some figure of the river training solution. One other important that you see in the very normal in Mekong, that the pond, the fish pond is very close to the river, and then when the flow is lower, then they have a collapsing pond, and then they have this kind of curve bank is important, like land loss in Canter city in different period of time.
One minute.
Okay. So let my go to discussion or maybe conclusion about the 8 river bifurcation is very important, and 8 location is should be focused. I think it's more nowadays we have like 150 kilometer bank erosion, but only a few protection by hard concrete. But I think it's maybe more friendly solutions should be taken into account in order to control this. Like permeable groy is one of apply in B1. Bottom van is not really applied under study, but sand draging is already measured. and I think it's some filing, and we are under construction and trying to study more about this 8 location for detailed application, and trying to keep the distribution of the flow in 8 branches in order to maintain and also to give the sediment and saline in a better situation. So thank you.
Thank you very much. Quite good into the time. Yeah, now it's 5 minutes to 6 in Vietnam. So we are all running a bit over time, almost half an hour. So that means that I don't think there is any time left for Q&A, but otherwise we get into conflict with the program. And so, but nevertheless, I think that just 1 or 2 lines for conclusions I would give is that I'm very much impressed by all the presentations, especially the quality of the information, and the fact that we are going. You see that there is a lot of modeling going on the main issues about salinity, about sedimentation, and all this information will give us more insight into the complexity of the delta, and hopefully this will, and I'm sure that this will give good information for the policy maker, for the decision maker. But you also see that there still needs some translation from the more technical work. I mean, much what I saw I cannot understand because I'm not a modeler. And also most of the decision makers are not modelers. So there is this bridge we need from all this very good, interesting
Hello, sorry, can I help you? Are there any technical difficulties at the moment?
Hello. Hello, Alina, can you hear me?
Yes, I can hear you.
Sorry, our session is kind of like over time, and it's linked back to this room. So
sorry?
we should sign out, right?
Did the session end already, or?
It's not end yet. It's
Okay.
about to end. Yes.
Okay, but the participants have technical difficulties currently, or the speaker?
I think the whole session, we lost the connection, and now, yes.
Okay. I will let my colleagues know. Just a second, sorry.
Thank you very much.
Yeah.